Okay. Looks like everyone got answers so quickly. Easy one. I think I told you about this concept in the offline class day before yesterday, if you remember that. Point arithmetics. You remember that concept? I think did I discuss with you in the group in the auditorium we discussed, right? Yeah, point arithmetics concept. Exactly. So whenever I add one for a point, what will happen? It will just take the next block's address, one block ahead's address. So what is one block ahead? Initially, what will ARR store? ARR will by default store the first address. That means address of 4 it will be storing. When I write ARR plus 1, that is what? Next block's address, which is nothing but 5's address. 5's address we are storing in P. And then when I write print RP, it will print value at P. What is value at P? 4. That's it. Okay. Voice is breaking. Just a second. Sorry for that. I think because of the internet issue. Just a minute, boys and girls. Answer is 5. Yes, it's correct. Okay, let's see the next. I hope this is clear. This question is clear, everyone. Question else. Can I go for the next one? Okay, see the next one. See this question. The question of recursion. Please use pen and paper and do it carefully. Easy one, but just be cautious. Just be cautious. They're asking what is the output specifically. Be careful. Okay, cool. Looks like everyone got the answer. Saying option C, 1, 2, 3, 4, 5. Okay, so yeah, it's very simple one. First, we have n as 1. When n is 1, it will call the function 1 greater than 5. It's false. So it will go out of it. Out of it, we have print n. So we'll print 1. After printing 1, we are calling the function with n plus 1. That means we are calling the function with 2. For 2, what will happen? It will check 2 greater than 5. Is it true? No, it's not true. So it will come and print 2. Will be printed. And I can call the function with 3. So for 3, what will happen? It will call the function 3 greater than 5. False. It will print 3. And then again calls the function with 4. For 4, what will happen? 4 greater than 5. Is it true? False. So again prints 4, then goes for 5. 5 greater than 5. Is it true? False. So prints 5. Then again calls the function with 6. For 6, what will happen? 6 greater than 5. True. When it is true, what we are doing? Exit. Directly exit. So what is the output we got? 1, 2, 3, 4, 5. Clear, everyone? 1, 2, 3, 4, 5 is the output. Yes, exactly. What you got is correct. If any doubts, please ask. If not, let's go for the next one. Answer is 1, 2, 3, 4, 5. Not none of the above. Answer is what you said is correct. 1, 2, 3, 4, 5. Don't worry about the options. Okay, just see this one. It's a theory question. I think if you know this concept of binary tree, maybe you can answer. It is about terminology. What terminology we use in terms of trees and binary trees concept. I think here we have all the branch students, right? Have you all studied data structures anything? Or is there anyone who don't know data structures? I guess everyone would have studied data structure at least once, some data structures. Oh, so people are answering terminal node. Do you have mechanical civil student, anyone in the group? If you have it, I think for them, I might need to describe something about binary tree. If they are there, I'll let you know. Or you also know it. Okay, there are there. Okay, there are a few people. Very simple thing, boys and girls. Just try to understand. For people who don't know about binary tree, I'm just telling about it. What is binary tree is nothing. Actually, first, what is tree? Tree is nothing but it's a non-linear data structure. Okay, is my voice clear now? Boys and girls? Oh, still I didn't get the Wi-Fi. Okay, I hope now it will be even more clear. I hope I am audible. Okay, so yeah, I was talking about tree. First thing, what is tree? Tree is a non-linear data structure. Actually speaking, data structures are classified into two types. One is linear and the other one is non-linear. Okay. In linear data structures, we have arrays, stacks, queues, linked list. Okay, I'm just writing it in single words. Arrays, stacks, queues, linked list. In linked list, again we have types: single linked list, double linked list. Okay, SLL, ELL. I consider it in shortcuts. Single linked list, double linked list. Now in nonlinear data structures, what we have? Trees, graphs, and trie. These are the three things we consider. TRIE. Okay, but we don't need to worry all about all of them. Only thing is trees and graphs. Tries is not a big deal. Trees and graphs, consider them. So non-linear data structure means what? They won't be arranged in linear order. They'll be random collection of elements. So in that non-linear data structures, we arrange elements like this. For example, if I have to show, elements will be like this. Here one, here two, here three. This is simple example of tree like this. In an array, it will be like this, right? A linked list also, they will be in linear order. But in case of trees, the elements will be like this. Okay. Now in this, we need to know the terminology. The first node in the tree is called as root node. Person else. The first node is called as what? Root node. I mean, A is considered as root node. And B and C are considered as terminal nodes. Okay. Terminal nodes. We call it as terminal nodes. Now, what is binary tree? Sir, just you are telling, but is it binary or not? Very simple. Binary means what? What is in binary means two. So if in the tree we have two children at most, then it is called as binary tree. For example, I'll draw a tree like this. I have a tree with three children with for the root. Can I consider this as a binary tree? This binary tree or not? What do you say, boys and girls? Can I consider this as a binary tree or not? No, obviously. Why? Because binary tree means maximum number of children for any node, any subtree, or anywhere. It should be only two. If there are any three nodes, and one, it can be one also. Okay? It can be one children also, but it should not be more than two. That's it. But here the root node has two children, right? Sorry, three children, right? So it's not a binary tree. Now in binary tree, this is called as root node. These are called as terminal nodes. There are some other terminologies also. They're also called as child nodes. And root node is also called as parent node. And one more thing, B and C are also called as sibling nodes. Try to understand. B and C are also called as sibling nodes. Why are they called as sibling nodes? Very simple. If two nodes have a common parent, they are called as sibling nodes. That's it. Okay. Remember it, people who are writing notes, note it down somewhere. What are sibling nodes? If two nodes have a common parent, then it is called as a sibling node. Sibling nodes. Example, if you want, you can take it down. I'm trying a bit bigger tree so that I can explain one more concept. Like this, assume I have a tree like this. Let's consider some numbers 1, 2, 3, and 4, 5, 6, and 7. numbers like this are there. Now tell me, yes, can I call 6 and 7 as sibling nodes? 6 and 7 as sibling nodes. Can I call it? Yes or no? Person will tell me yes or no. Can I call 6 and 7 as sibling nodes or not? Obviously, yes. Okay. One more small question. Can I call 5 and 6 as sibling nodes? 5 and 6 as sibling nodes? Yes or no? No. Okay. Those nodes are called as, what are they called as? 5 and 6, what is the name I should consider them as? Okay, one thing I can consider leaf node or terminal nodes, that is fine. Any other terminology? They can be called as cousin nodes. Like our normal blood relations. Two people who have a common grandparent are called as what? Cousins, right? Cousin nodes, like that. Okay? Cousin nodes. Got it, everyone? Two nodes which have a common grandparent are called as cousin nodes. If you are writing some notes or anything, please note down the points. First point which I told was for say child nodes, or I mean sibling nodes. Sibling node means any two nodes which have a common parent are called as sibling nodes. I hope you are making notes. And for cousin nodes, what is it? What is the definition? Any two nodes which have a common grandparent is called as cousin nodes. Okay. So yeah, in this for this question, answer is terminal nodes. Okay. Going for the next one. Next. This question, everyone. Okay, everyone got the answer as C. Oh, I see few people saying D. C or D? Be cautious. C, B, D. I got multiple answers. Check again. 30 seconds more. If you want to change your answers. Okay. For people who are saying D, can you just let me know what is the answer you got? None of the above means, I mean, some other answer you would have got. What is the answer you got? Oh, 1, 3, 3 you got. Okay, fine. Looks like only 2 times 3 you got. You will see that. They're asking what is the output of the pseudocode. I mean, that means what is the printing value we have to consider. Need not consider written statements. Okay. Well, because think about that. Because we don't know whether written value is getting printed or not. Maybe they are using for something else or not. We don't know. So we have to consider only the printing values. Think in that terms and tell the answer. Only printing values we have to consider. Okay. Can I explain? If you got it, let's see the explanation. Okay, cool. See that C is initially 1. First, I am calling the function with 1. In that, C is 1. It is checking. First, without checking anything, first it is printing 1. So I'll write it. First output is 1. I'm writing it on the top right. Next, 1 less than 3. True. As it is true, it will enter inside and then C equal to C plus 2. In the same function, C got updated as 3 right now. C is not 1 anymore. It's 3. Now, after making it 3, I'm calling the function with currency, which is nothing but fun of 3. Right? So it will call the function with 3. Now it will be in this function, C value is 3. Now 3 less than 3. Is it true? 3 less than 3 is what? False only, right? That means what? Again, it will enter inside. C less than 3 is false. 3 less than 3 is true or false? False, right? Then why did you got 1, 3? I didn't understand that. C 3 less than 3 is what? False. So as it is false, it will come out of if. Out of if, what is there? Directly written. Are you print only? We are printing only 1, right? Okay, sorry. My mistake. So when we call 3, first it will print 3. Yeah. Sorry. Print C. I missed that. Yeah, got it. We printed 3, and then again, as if it's false, it will come out of it, return 3. 3 is nothing but 3, it will return 3. Are we printing 3 again? No. We printed only twice. 1, 3. Yeah, fine, boys and girls. Answer is option C. Okay. Answer is option C. Not none of the above, not 1, 3, 3. If I have to consider the return value also, then it is 1, 3, 3. But here they are asking what is the output. So only 2 times we are printing, that is 1, 3. Okay. Got it? People who said other answers, I hope it's clear. If any doubts, please ask. Going for the next one. Cool. Try this, everyone. Okay. Everyone says answer is goodbye. Okay. So option A, everyone. Nobody says option B. Option B. Few says option B also. Okay. I got 1 or 2 people saying B, but majority is saying A. Cross check quite carefully. It's about simple additions, I guess, right? Nothing else is there. R equals to -1. Okay. R is -1. If it's not visible or anything like that. Okay. Let's see the answer. P is equals to P plus Q plus R minus 9. That means what? 2 plus 7 plus 7 plus R means 7 plus or minus will become minus only, right? -1 minus 9. What will that be? 2 plus 7 minus 1 minus 9. What do you got? -1. Am I right? -1 only? Yes. P value is -1. Okay. We modified only P value, not Q value or not R value. Okay. Only P value is -1 now. Then again, now we are taking Q. Q is equals to P plus R minus 9. -1, -1, -9. That's all right. Plus minus will become minus only, right? Personals, is that what I'm talking? -1, -1, -9 is what? -11. As we said, yes. Q is -11. Now P was -1, Q is -11. Now we are taking P greater than Q. What is P? -1. -1 greater than -11. It's true, right? -1 is bigger value than compared to -11. And it is true, answer is goodbye. Got it? Simple one. Just need to be cautious about the symbols there. Okay. Answer is goodbye. Be cautious about the subtraction. Answer is goodbye. Clear, everyone? I hope everyone got it. Okay, try this one, everyone. It's a bit lengthy one, I guess. Just try it carefully. Looks like lengthy one. Still trying, I guess. Hope everyone is trying. I got only one response, 45. Remaining people also please try. Okay, now I got some responses saying C, 32. What about others? Only 5 or 6 people responded. What about not even 5? Only two people or 3 people. That's all. C. Okay. Looks everyone says C now. Okay, fine, boys and girls. So yeah, what's the question actually? It is like we have to find the sum of n natural numbers. When will be the sum of n natural numbers greater than 500? If I'm not wrong. So I think that's the question, right? Is that correct? What I'm saying? If sum of n natural numbers is greater than 500, in that case, output will be printed. If not, it will keep adding the I. If it will keep adding I value to the sum. That's all right. Let us see that. If we see 1 or 2 iterations, maybe you will understand what is happening. So first I is 1, sum equal to sum plus I. That means 1 is added. So sum value will be 1. Now we are taking sum is greater than 500 or not. It's greater than 500. Is it true? No. So it will go to else part and I equal to I plus 1. I value will become 2. When I is 2, what happens? Goes to line 3. Line 3 is this one. Sum equal to sum plus I. Sum was 1. That will become 1 plus 2, which is nothing but 3. Right? And then 3 greater than 500 false. Comes to the else part. I will become 3. Sum will become 6. Go to line 3. Sum will become 6. 6 greater than 500. 0? No. Again, come to the else part. Like, yeah. By now, you would have understood. What is it doing? It is adding 1, 2, 3 for S continuously and checking whether that result is greater than 500 or not. Am I right? Person else understood that? Next, it will become 4. 4 will get added, it will become 10. 10 will check whether it is greater than 10 or not, greater than 500 or not. It's all right. So now for what options, it is the smallest number at which sum of n natural numbers will reach above 500 from these options if I have to choose. If I have to choose from the options, at which case the number will reach above 500. What is sum of 30 natural numbers? 30 plus n into n plus 1 by 2. Am I right? 31 by 2. Calculate that. What is that? If I consider 30. What will I get? N into n plus 1 by 2. That's all, right? I'll get 465 if I'm not wrong. Right, for 30. I have to still keep going on. So let us check 465. If I check directly with 32, what will I get? 32 plus 33 by 2. N into n plus n plus 1 by 2, not plus, okay? N into, my mistake. N into n plus 1 by 2. 32 into 33 by 2. What are you getting? 528. So that 528 is greater than 500. That's why it will print 5 I value. This is nothing but 32. Okay, for 31, what is the answer then? Can't it be 31? 31 into 32 by 2. What is the answer for that? I think it's borderline something like 400, 490 something will get, if I'm not wrong. 31 into 32. 490 or 486. 496, I guess, right? Yeah, 496. So it's not greater than 500 anyways. Okay. So only thing which is possible is by adding 32 for it, which will I get 32 the answer. Got it? I hope everyone understood that. In this case, these kind of questions go with option elimination. That would be better. Here I need the smallest possible value. I'll check with 32. If first 28 I'll check, it's anyways lesser than 500. Then I'll go with 32. I hope you know the formula for n sum of n natural numbers. N into n plus 1 by 2. Okay, remember that. Okay, 32 is the answer. Don't worry about it. Yeah, try this one, everyone. If I'm not wrong, I think we did this question earlier. Did we do it or not? Or maybe something similar we have done. Similar one. Okay, okay. Not same, but similar one. Okay, cool. So if you got the answer as 35, others are still trying. Make it fast. Okay, fine. So 35. Oh, one person, one or two people said 25, 45 also. Some said 25, 45 also. Let us check. 25 plus 9 plus 1. One is said very clearly. 20, 30, 25 plus 9 plus 1. Okay, let's see the recursion. It's a recursion program again. I think for recursion only, I'm getting multiple answers. Other answers, majority of you are saying correct. But for recursion, there is some confusion. It's an easy one. It's not a difficult one. But majority says 35. Cool, great. Let us see. Initially, n is 5. For 5, what is happening? 5 is equal to 0. Okay, I'm just writing the block. In this block, n value is 5. For that, what will happen? N equal to 0 is false. N equals to 1 is false. It will come here. It is like 5 into 5, which is 25. 25 plus function of n minus 2. That means 5 minus 2, which is 3. So I'm calling return 25 plus some function call. So that will call the function with 3. So in this block, what is n value? 3. When n value is 3, again it is checked. 3 equals to 0, false. 3 equals to 1 is false. It will come to the else part. Last one. n into n, 3 into 3. What is 3 3s? 9. Plus f of 3 minus 1, fun of 1. Am I right? This function of 1. So it will call the function with 1. Now for n equals to 1 in this block, what will happen? It will check 1 equal to 0 false, 1 equals to 1 is true, returns 1. This function will return 1. Where will it return 1? The place where it is being called. We call it here. So here, I'll get the value called 1. Right? This 9 plus 1 is 10. That value will be returned to the place where I called it. I called it here. So f of 3 will be replaced with 10. So 25 plus 10 is 35. So the answer is 35. Someone who said 25 plus 9 plus 1. Perfect. Great. Okay. At 1, it is getting terminated, returning 1. I hope everyone understood that. So answer is once again, okay. For people who got it, just bear with it. Again, who didn't get it, just listen again. First, we are calling the function with 5. That is a main function call. In that, we are calling the function with 5. In that, if we call, you can check the condition. 5 equals to 0, false. 5 equals to 1, false. 5, so it will go to the else part. It is like if else. Otherwise, if else, otherwise means else if else. Okay. So it will come to the last one. It's n into n. So nothing but 5 into 5. 5 into 5 is 25 plus fun of n minus 2. Means what is n value in this function? 5. 5 minus 2 is 3. F of 3. So this block is called. Again, in that block, what is happening? N is 3 in this block. Remember, whatever n value we get 3, that return value will be replaced in the place of f of 3. That's all right, recursion means. For n equal to 3, again it is check. T equal to 0 false, t equal to 1 false. It will come to the else part. So that will be what? 3 into 3. Return 3 into 3 plus f of n minus 1. Sorry, n minus 2. F of 3 minus 2. What is nothing but 1. So 3 into 3 is what? 9. I'll write that. 9 plus f of 1. But f of 1, again, if you call the function 1 as n. N is 1 in this block. Now in this block, what will happen? 1 equal to 0, false. 1 equal to 1, true. As it is true, return 1. Where will it return? Wherever we call this function. I call this function here. So this f of 1 we can be replaced with 1. I'll write that it was 9 plus 1. Got it? This 9 plus 1 is 10. Where will I return this? Wherever I call this block. What did I call this here? That means f of 3 will be replaced with 10. 25 plus 10 is what? 35. That will be returned to the main. Got the answer? Hope it's clear now. Clear, everyone? Okay. Can I go for the next one? Someone who said me to repeat. I hope it's clear now. Okay. Okay. Fine. Now, as you asked, I'll go for that bitwise MCQs. Just a second. Bit calculation MCQs you asked. I'll go for it. We have, I mean, before 1 hour, I'll just go for it once again. People who asked bit questions, just even if I think the count is also reduced, people try to let your friends know that I'm going to discuss that bit questions which you got yesterday. Not only bit questions, I'll discuss some other questions also. Just see that. Okay, this is also bit questions. Okay, first thing, question wills. Before getting into bitwise operators questions, let me know first thing. I hope you know binary representation, everyone. Yes or no? Everyone knows binary representations? Yes. Okay. In your notes, whatever the notes you are carrying, please note down these things which I am telling now. So first, what is the value of last digit of binary values? If you don't know also, no problem, it's in here. Binary numbers means what? It consists of zeros and ones. So binary values, digit value will be in terms of powers of 2. So what is the last digit value? It's nothing but 2 power 0. 2 power 0 means what? Any number power 0 is 1. Okay. Next. What is the next digit value? 2 power 1. 2 power 1 means what? 2 power 1 means 2. Next we have next digit as 2 power 2. What is 2 power 2? 4. Next we'll have 2 power 3. What is 2 power 3? 8. 2 power 4? 10. 2 power 5? 32. Okay, these are the digit values. But now, along with this, if possible, we have to remember one more thing also. What is that is nothing but if I tell you to use some number of bits, what is the maximum number you can represent using that bits? Okay, for example, I'm telling that you can use only one bit. Only one bit you can use. What is the maximum number you can represent using one bit? Maximum number that you can represent using one bit. What is it? One bit means what we can write? Only one. Either I can write one or either I can write zero. So minimum value is zero. Maximum value is one, which I can represent. That's all. Yes, exactly. Okay. So maximum value with one bit is one. Okay. What is the maximum value with two bits? What is the maximum value that you can represent using two bits? Yeah. What are the numbers I can represent? Is nothing but 1 to 3. What is the largest number I'm asking only? I can. Two bits means maybe both I can 1 1. If I make both as 1 1, what is the value? 2 power 0 plus 2 power 1. It's nothing but 3. Exactly. Super. Next, same way. What is the maximum number you can represent using 3 bits? 3 bits. Can you tell me, everyone? Super. 7. Okay. Boys and girls. Now tell me, we don't need to manually write three ones and calculate it. It is simply, if I tell 4 bits, calculate 2 power 4 and do -1 for it. What is 2 power? If, for example, I am asking you, what is the maximum number that you can represent using 4 bits? Then what I'll do, I'll calculate 2 power 4. What is 2 power 4? 16. 16 minus 1? So the maximum number I can represent using 4 bits is 15. Did you understand that? What I'm saying? 2 power number of bits minus 1. Okay. 2 power number of bits minus 1. Now, for example, I'll ask you, what is the maximum number you can represent using 5 bits? We'll calculate 2 power 5 minus 1. What is 2 power 5? 32. 32 minus 1? 31. All right. Next, what is the maximum number you can represent using 6 bits? Everyone must say 6 bits. What is the maximum number you can represent? I got only one response. Everyone, others also. What's the answer? 2 power 6 minus 1. 2 power 6 is 64. 64 minus 1 is 63. 63, not 127. Next one is 127. If I ask for 7 bits, that is 127. If you can calculate. Simple example, if I ask you, what is number of bits, the maximum value I can represent using 10 bits? 10 bits. What is it? 10 bits. What is the value of 2 power 10? 2 power 10 value. If you know 2 power 10 value, we can easily tell. 2 power 10 value is what? 1024. Am I right? Yeah, 1024 minus 1 if I do, that is the maximum number I can represent. 1023. Clear, everyone? So yeah, see, else. This chart, I mean this table which I have written here. The table which I have written here will help you a lot and lot to solve this bitwise questions, bit calculation questions. So whenever you get, I mean, if you can remember, it's fine. If not, whenever you see this kind of bit questions, note on this table. Okay. This is 1 bit, 2 bits, 3 bits, 4 bits, 5 bits, 6 bits. Okay. In a rough paper, just write this table. If you write this table, then we can answer a lot of questions easily. Okay. I hope you would have, please make a note of this table, this similar table in your notes. Boys and girls, I hope you are carrying the notes. Please write it in your notes. But I think it's not that clear to take screenshot also. Better you write it in your notes. If you think you can understand and you can manage with it, maybe you can take screenshot. Yeah. Meanwhile, I'll explain again. Others who are writing in the notes, please write it. Very simple, dear. It's very simple thing. Here, first, I'm writing the digit values of binary numbers. Digit values of binary numbers, each value will always be in terms of powers of 2. So if I want to write, if I want to use only one bit, I can represent 2 power 0 value in it. What's 2 power 0? 1. That I can represent. Digit value of 2 power 0 is 1. Now, if I want to tell like ones digit, tens digit in decimal number system, digit values will be in terms of powers of 10. I hope you know that. 10 power 0, 10 power 1, 10 power 2, 10 power 3, like that it will be. I mean, ones, tens, hundreds, thousands, 10,000s, like that, so on and continue. Same, if I consider binary number system, digit value will be in terms of powers of 2. Octal number system means what? Digit values will be in terms of powers of 8. Hexadecimal means digit values will be in terms of powers of 16. Like that. In total, we have 4 number systems: binary, decimal, binary, octal, decimal, hexadecimal. Okay. So now, if I am talking about base 2 number system, digit values will be in terms of powers of 2. 2 power 0 value is 1. 2 power 1 value is 2. The second digit value in a binary number system is 2. Third digit value is nothing but 2 power 2, which is 4. Next, fourth digit value is 2 power 3. It's nothing but 8. Like this, I can define digit values. Okay. The same thing, if I want to write, okay, in decimal number system, if I ask you, using 3 digits, what is the maximum number you can write? What will you tell? Question else. In decimal number system, you have to use 3 digits. What is the maximum number you can write? What will you do? 10 power 3 minus 1. That's all right. What is 10 power 3? 1000. 1000 minus 1 is 999. Same way, in same thing, binary number system also. If I ask you, what is the maximum number you can represent using 3 bits? I'll write 2 power 3 minus 1. What is 2 power 3 minus 1? 2 power 3 is 8. 8 minus 1 is 7. So if I write 3 bits, that is nothing but 111. What is the value of 111? 7. Right? Which is nothing but, how do I calculate that value? 4 plus 3 plus 1. What is 4 plus 3 plus 1? 7. Understood that? Like that, I am defining digit values, all the values for but maximum number I can represent for whatever the number of bits I want. If I ask you 10 bits also, I can simply tell 2 power 10 minus 1. If I ask you 5 bits, 2 power 5 minus 1 is the number I can represent. Okay, same like decimal number system, there we have 10 power something. There we have binary number system, means 2 power something. Understood, everyone? I hope it's clear. If you are clear with this topic, then we can answer that bitwise question easily. Can I erase it? Everyone is clear with it? Have you noted in your notes, everyone? Noted. Can I move on? Yes or no? Question else. Is it done noting? Hope you have written the table. Last line. Aditya, you mean this line? This value 63, 31, 15, 7, 31. Is that what you are asking? Okay. These are nothing but see. Aditya, if I use 1 bit, what is the maximum number I can use represent using 1 bit? That is nothing but 2 power 1 minus 1. What is 2 power 1 minus 1? 2 power 1 is 2. 2 minus 1 is 1. That's what I have written here. Now, if I say 2 bits, if I use 2 bits, what is the maximum number I can use represent? 2 power 2 minus 1. 2 power 2 is 4. 4 minus 1 is 3. So I can write a maximum number called 3 using 2 bits. That's what I have written. Same thing. If I use 3 bits, what is the maximum number I can write? 3 bits means what? Maybe I can write 3 ones. What is the maximum number I can get? 3 ones means 7. But instead of calculating like writing 3 ones, I'll take 2 power 3 minus 1. What's 2 power 3 minus 1? 8 minus 1, 7. Got it? Next, if I tell 4 bits, if I can use 4 bits, I can represent 2 power 4 minus 1 values. 2 power 4 minus 1 is what? 16 minus 1, 15. Understood that? Is it clear, Aditya? I hope others also it's clear. Okay. Let's see the question now. Let's see the question, everyone. Don't worry. I'll repeat again those topics with the question. Let's see this question now. Try to answer this, everyone. Okay. I hope everyone understood the question and got the answer. Very simple thing. There is a new data type which can take as values natural numbers between 0 to 25. So we have great 0 to 25 numbers. How many minimum bits are required to store this data type? 25 is 25 is the largest number, right? To store 25, what is the how many bits we need? How many bits we need? 25? 5 bits? Okay. What if I say okay? What is the maximum number you can represent for 4 bits? 2 power 4 minus 1. What is 2 power 4 minus 1? 10. Right? So 4 bits is not possible. 5 bits, what is the number you can represent? 2 power 5 minus 1. 2 power 5 minus 1 is what? 32 minus 1, 31. So within 31, you can represent 25? Yes. That's why the answer is 5 bits. It's not 4 bits because the maximum number you can represent using 4 bits was 15. So I cannot represent using 4 bits. So answer is 5 bits. Understood everyone? Question else got it? This is how we answer these questions. Okay. Going for the next one, try this. Maybe in the exam you would have got some similar questions like this only. Saying minus 12. What's the answer, personals? Others, please try. See the question carefully. A data type is stored as an 6-bit signed integer. Which of the following cannot be represented by the data type? Cannot be. Okay, one small thing, before answering, tell me, signed integer means what? What is the specialty of signed integer? Signed integer means what? We have to store the sign also. Am I right? Both negative and positive. We have to store the sign also. For storing sign, we need 1 bit. Am I right? 1 bit will be gone for storing the sign. Okay. So that means what? The maximum bits you can use in this is 5 bits. You can use only 5 bits because 1 bit is gone for sign. The remaining bits are 5. Using 5 bits, what are the numbers you can represent? Okay. What's the maximum number you can represent using 5 bits? 2 power 5 minus 1. What is 2 power 5 minus 1? 31. So that means only 31 you can represent. Maybe plus 31, minus 31, both you can represent. But can you represent 32? No. Right? For representing 32, we need total of 7 bits. If it is plus 32, we need 6 bits. If it is minus 32, we need 7 bits. As it is signed integer, we have to consider sign also. So for sign, we'll use 1 bit. And for the remaining numbers, we use for the remaining bits we use represent for number. So 5 bits maximum is 31. So I cannot represent 32. I hope everyone understood that. Answer is 32. Clear? People who said other answers, 1 or 2 people said other answers. I hope you got it. Signed integer means we have to store the sign also. Unsigned integer means no need to store the sign. Okay. Unsigned integer means only positive values we'll consider. We don't need to store the sign specially for that. No need to allocate 1 byte for it. Yeah. Simple thing, boys and girls, just see that. The total number of bits they have, okay, data type is stored as a 6-bit signed integer. 6-bit signed integer means what? 5 bits for number, 1 bit for sign. If it is negative number, we'll write it as 0 and then the number. And then if it is positive number, we'll write 1 and then the number. Something like that we'll write. Okay. We will store 0 or 1 as in the place of sign. And then in 5 bits, we'll write the number. So we have only 5 bits for storing the number, right? 1 bit for the sign. That is done. So 5 bits, what is the maximum number you can represent? 2 power 5 minus 1. What is 2 power 5 minus 1? 32 minus 1. That means 31. So 31 is the maximum number you can represent using 6 bits of signed integer. For a signed integer, if it is 6-bit signed integer, in that we can use only 5 bits for the number. In that 5 bits, we can represent maximum of 32. Sorry, maximum of 31. So which number I cannot represent? 32 I cannot represent. Can I represent 0? Yes. Can I represent minus 12? Obviously, yes. Right? And can I represent 18? Obviously, yes. Only thing which I cannot is 32. Plus 31 to minus 31, we can represent. Okay. Plus 31 to minus 31, we can write it. If I write 5 ones and that initial one 0 or 1, it becomes plus 32 or minus 32. Got it, I guess. Cool. Going for the next one. Try this. Cool. Okay. Did you get this question in the exam? 7 letters word. I think you got it. Okay. Try it now. I hope you understood the concept now. So you should be able to answer correct for sure now. So try it. Be cautious. Take time. Not a problem. Nothing to hurry as of now. Think twice and answer. Got the answer, everyone? I see only few answers. What happened? What happened? Nobody gave the answer yet. Okay. 7. Few says 7. Few says 35. Okay. Still trying, I guess. Make it fast. Read the question carefully. Read it twice and try to understand it carefully. 196. Oh, I got different answers. Giving time again. Just try it carefully. Others also please try. Important one. Please try it carefully. You'll see these kind of questions. You'll see a lot DXC exam. Okay. In actually this like DXC questions. These kind of questions come a lot. Lot of times these are repeated in DXC. Seven 35, 735. Still a lot of confusions going on. Make it fast. If you want to cross check your answers, read it once again and cross check your answers. I'm giving 1 more minute. Answer it before 1 minute. Okay. I hope I gave enough time. I got the last few answers as 28. So few people just 35. Okay, so much confusion for this question. 25, 38, 7. I got all the answers from you all. All the 4 answers were given. 7. Okay. Okay. Just read it, see it carefully. Try to do it along with me. Okay. A language has 28 different letters in total. Okay. How many letters are there? 28 different letters. Letters are 28. Next. Each word in the language is composed of maximum of 7 letters. So each letter is 28, but each word will have 7 letters. 4, 5, 6, 7. 7 letters are there. Now you want to create a data type to store a word of this language. You decide to store the word as an array of letters. How many bits will you assign to the data type to be able to store all kinds of words of the language? So see, we have to create a data type in which we can store any word given. Okay, for example, 28 letters are there, right? Let us assume A to Z alphabets are there. And there is one more alphabet called alpha and beta. Okay, A to Z, then alpha, beta are there. Now tell me, see, in general, if you want to represent a letter, how do we represent in C language? We represent through ASCII values. But yeah, are they talking about C language or anything like that? No, we are creating our own language, right? So I can give my own ASCII codes. I can give my own ASCII values, right? In C language, ASCII value of C is 97. Small a is 97. But in my language, I generate ASCII value of small a as 0. Because only letters are there. 28 letters are there. That's it. So I'll write 28, A as 0. Then Z will be what? 25. Alpha will be what? 26. Beta will be what? 27. So what is the maximum ASCII value in my language, in the language which we are creating? What is the largest number you have to store? 27. Am I right, boys and girls? If you want to store one letter, you have to store 27 number. The number 27. Any number from 0 to 27, you have to store one letter. Okay. To store one letter called 27, a code called 27, how many bits we need? For 27, how many bits we need? To represent 27 in binary, how many bits we need? I need 5 bits. Exactly. Because 31 is the maximum number I can represent for 5 bits. If I take 4 bits, it's not possible. So I have to take something around 5 bits. So 5 bits per letter. For one letter, I need 5 bits. One letter, 5 bits. Like that, how many letters are there in the language? Maximum 7 letters. That means what? 5 bits per letter means 7 letters means 5 into 7. What is that? 25. Am I right? Boys and girls, understood that? Per letter, 7 bit, per letter I need 5 bits. Per 5 bits per letter means 7 letters. How many bits? 7 into 5 bits, which is nothing but 35 bits. Understood? Is it clear, everyone, or should I repeat anything? Once again, few says once again. Others repeat. Okay, I think majority of the people needs once again repeating. Don't worry. Here, very simple. I have 28 different letters. Assume that the alphabets are like A, B, C, D, so on till Z. Okay, and then 28 letters, right? A to Z are 26 only. And alpha, beta, I'm taking it as 2 new alphabets. And we are creating our own language with A to Z alphabets and alpha, beta also as the characters in it. So I'll write ASCII value of A as 0. My own ASCII values. B will be 1, C will be 2, and so on. Z will be 25. Alpha will be 26. Beta will be 27. Because tell me, can you store an alphabet directly in a language? In any programming language, can you store alphabet directly? No. Only possibility is by storing their ASCII value. Some number we have to write for an alphabet. So what I'm doing is, for my language which I'm creating, I'm assuming that the numbers are like 0 to 27. Because 28 letters. So if I want to store beta anywhere, I'll store 27. If I want to store Z anywhere, I'll store 25. It's done. I can store the letters. So to store one letter, worst possible letter is what? Any letter. You have to create a data type. You can store any letter. How will you create? With the maximum possible. Right? What is the maximum possible? Beta. Beta, what you have to store? 27. If you want to store 27, how many bits we need for that letter? 5 bits. Because only using 5 bits only, you can represent 27. Can you represent 27 using 4 bits? Is it possible? Can you write it? using 4 bits, can you represent 27? For binary. Not possible, right? It's impossible. That's why we go with 5 bits. So that means what? In the language which I am creating, for letter, for one letter, I'll need 5 bits for one letter. But in that language, how many letters are there? Maximum letters are there. In a word, 7 letters are there in maximum. In a word, maximum number of letters are 7. That means what? Per letter, I want 5 bits. For 7 letters, how many bits I need? 5 into 7 bits, which is 35 bits. Understood that now? Is it clear now? Person else, is it clear now? Per letter 5 bits, per 7 letters, 5 into 7 bits, which is nothing but 35 bits I need. How many bits will you assign to the data type? 35 bit data type I'll take. I hope it's clear. Or still any confusion? Clear or not, boys and girls? You asked me to repeat. How do we get 5? Simple here. Aditya, 5 I got because I want to store 5 bits. See, I want to store 28 letters. 28th letter. If I want to store 28th letter, how many bits I need? 28th letter means what should I store? Maybe I'll store 27 or 28. Let us assume 28 only I'll store. I want to store how many bits I need for 28? Tell me that. If I should store 28 in a language, how many bits I need for storing 28, 27, anything? 5 bits. That's what I'm talking. So for one letter can store maximum of one letter should be maximum number is 28. That means per letter I need maximum of 5 bits. Worst case I need 5 bits. So whenever we are creating data type, we'll create for the worst case possible, right? We'll not tell, okay, I want to store A, I'll create 1 bit data type. But that will work only for A. But I want to create a data type which can store any alphabet. That's why I'll create a data type with 5 bits per letter. 5 bits per letter. But they are not asking for per letter data type. They're asking for per word, what is the data type? Per word means what? How many maximum letters are there in the word? See, I can write a word like AB. That's the word I'll tell in the language. Or maybe I can write all 7 letters A, B, C, D, E, F. Okay. A, B, C, D, E, F, 1, 2, 3, 6, 7, G. This is the word I'll tell that you have to store. Now for storing this word, how many bits we need? Per letter, you need how many bits? Maximum 5 bits. Like that, 5, 5, 5, 5, 5, you need 7 times. It's 5 into 7 bits we need. Do you agree? Understood that? Is it clear now, Aditya? And others who asked for repetition? Understood, I guess, everyone? We are creating the data type for the worst case possible. I'll tell that you have to store 7 betas. What is the value of ASCII value of beta in our language? 27. That means 7 times you have to store 27. How many bits you need? 5 bits per letter. Total 35 bits I need. Okay, that's the answer. Cool. I hope everyone understood. Still any doubts? Ask where you are getting doubt. If not, don't worry, we'll discuss again. Going for the next question. Answer is 35 for this. Okay. This question, everyone. Easy one. This one, I think you can answer it directly. Please answer this, everyone. 10-bit unsigned integer has the following range. Exactly. Because we just before, I think I asked you just before, what is the maximum number you can represent using 10 bits? 2 power 10 minus 1. 2 power 10 is 1024. That means you can store the maximum number is 1023. So 0 to 1023 numbers we can store. Yes, dear. Sir, we can also start ASCII values from other. Yes. See, when we are creating our own data type, we'll try to create the efficient one, right? Am I right? We will try to create the most efficient one. As less memory as possible, I'll try to allocate. If it's a predefined language, we cannot do anything. But if it's my own language, I'll try to create an efficient language, which I'll try to store minimum numbers possible for the character. But I cannot store duplicate numbers, so I'll store unique ASCII values starting from 0. Am I understood my justification? It is not if they mention that C language or Java or Python, we will take the the specified values like 97, 98, those values are given. But it's our own language, right? We are creating a language, we are creating a data type. That's why I was telling that. I hope you understood what I mean. Okay, next one. Going for the next one. This one everyone got. Next, try this one. Yeah, this is the question you got last time in the exam. Try it carefully. Just read the question carefully. Easy question, but just need to understand the question carefully. You know the concept now. You can try it. Think carefully. You'll get it. Take time. Read the question twice, then answer it. Looks like if you got the answer. Some says 127, some says 52. Okay. Read the question carefully. Try to understand. Here, understanding the question is something which you need to do carefully. Answer is very simple. You can get the answer very easily. But understanding question is something which is you need to be cautious. People who said 127, read the question once again carefully, word to word. Okay, I guess everyone read the question. If needed, I am reading it out again. Raji wants to create a data type for a number of books in her shelf case. So Raji is someone, sorry, Rajni, I guess, right? Rajni wants to create a data type for what? For her books in the shelf. Now, her shelf can accommodate maximum of 75 books. How many books she can accommodate? Maximum 75 books. Okay. So she assumed that 75 books is maximum I'm going to store. So for 75 books, she is creating one data type. What is the data type? 7-bit data type she is taking. What is the data type? 7-bit data type. Now, in a 7-bit data type, tell me what is the maximum number you can represent in general, regardless of this question. Generally, what is the maximum number you can represent in 7-bit data type? Tell me, boys and girls. 2 power 7 minus 1. What is 2 power 7? 128. 128 minus 1 is 127. So the maximum number you can represent is 127. Okay. Maximum number you can represent is 127. 7-bit data type. Okay. Okay. Let's continue the question. Later, another shelf is added to her bookcase. She realizes that she can still use the same data type for storing the number of books in her bookcase. What is the maximum number of possible capacity of her newly added shelf? Newly added shelf, what is the maximum capacity she can store? See, in the first shelf, she stored how many books? Maximum 75 books. Right. From 76th book, 76, 77, 78, and so on, she'll keep storing in the second shelf. Till what is the largest number she can store? 127, right? Because it's a 7-bit data type. She cannot store beyond that. Am I right, boys and girls? 127th book she can store. So 76 to 127. How many numbers are there? 76 to 127. How many numbers are there? How many books are there from 76 to 127? What we'll do? 76 is inclusive. So one of them is inclusive, one of them should be exclusive, right? 52 books it will be. Okay. Got it? 52. Exactly. That's the answer. Okay. Number of numbers. Got it, everyone? 52 is the answer. That's the answer. Understood that, everyone? Is it clear now? Boys and girls. One more, sir. Okay. Any doubt or you want me to repeat the same thing? Very simple. I'll tell theory. I'll just say it. Listen carefully. First, the maximum number of books she can store, we don't know. But she is going to have, first she has one shelf. That capacity, she knows that it is 75. So she will store first 75. But later she got another shelf. That is also in general maybe 75 or something like that. We don't know. But she assumed that it is the 75, so I can take 7-bit data type. That's enough. He thought. So for 7-bit data type, what is the maximum number of books she can store? 127 books she can store. Okay, 127 books she can store. Now in the first shelf, how many books she stored? 75 books already stored. Now they are asking how many books she can store maximum in second shelf. That means what? From book number 75 are done. So up to 127 she can store. That means what? 76 to 127. So what are the numbers between, count the number of numbers between 76 to 127? Those are 52 books. Okay, simple thing. 127 minus 75. 75 was the last book, right? 127 minus 75 is 52. That's the answer. I hope you understood that. Here, going for the next one. If still any confusion, please ask. If not, going for the next one. Yeah, please try this, everyone. Someone was asking again, explain, sir, before question. Okay, before question again. Yeah, I'll discuss that. Okay, don't worry. I'll discuss that once again. After some time, I'll discuss. Okay, as I think people are trying this question. After this question, I'll go back and I'll explain that. Okay, dear. Right now, try this question. After that, I'll again go back and I'll explain. First, try this. Everyone, please try this right now. Okay, few says 4 and 5, few says I got few more. Okay, majority saying 4 and 5, but one said 4 and 3. Okay. Others, what happened? Only 2 or 3 people are responding. Boys and girls, if you are not interactive, it will not be interesting. You have to respond to the answers, then only you will feel interested. You have to do the answer, calculate it, then respond, then only you will feel interested. So try to do the answers and do respond. 4 and 5, majority says 4 and 5. Cool, super, got it. Okay. If you feel that typing is difficult, just type the number, option number 1, option number 2, at least that will also work. 4 and 4, is it so? Okay. Okay, let's see. Just see that. Now, a new language has 15 possible letters, 8 different kinds of punctuation marks, and a blank character. Okay. 8 different punctuation marks and 1 blank character. Now see, Rahul wants to create 2 data types. Okay, they are not creating 1 data type, they are creating 2 data types here. First one which could store letters of the language, and second one which could store any character in the language. The first one we are okay. Let us talk about letters. Okay, first one, how many letters? 15 letters. For storing 15, how many bits we need? For storing 15, how many bits we need? 4 bits exactly, because 2 power 4 minus 1 is 15. Okay, done. So for first creation of first data type, I use 4 bits. Okay, so that means option can be option 2 or option 3. These two can be answers. But yeah, now check second one also. Okay, what is the second one? Rahul wants to create the two data types, right? For second one, what is it? Letters and letters of the language done. So now 8 characters are there, plus 1 space is there, 1 blank space. So total 9 characters are there. So that means what? Okay. Last possible value was 15 for the letters. Now, what is the maximum possible value for characters? Okay. Can I take again from 0 to 9? Is it possible? Can I take again from 0 to 8? It's the same language, right? Can I give two different characters, same ASCII value? 15 letters are there. A to some alphabet is there. For A, I'll assume that it is 0. Can I again take for 9 different kinds of punctuations? Let us assume comma, semicolon, like this, some punctuations are there. Can I again take comma as 0? No, it's not allowed. Duplication of ASCII values is not allowed, right? Cannot take. So I have to take from where 16, I have to take 16, 17, 18, 19, like that will come. So it is like 15 plus 9. What is 15 plus 9? 24. Am I right? 24 is the maximum value I might need to store for the punctuation marks. Right? So for storing 24, how many bits we need? For storing 24, how many bits we need? 5 bits. So the answer is what? 4 and 5. Understood that, everyone? As we cannot duplicate the ASCII values, we have to continue. We should not repeat from 0. We have to continue from 15, 16, 17, 18. Actually speaking, 15 letters means 0 to 14. And then 15 to 1 is the new different punctuation mark. 15 to 26 is the punctuation marks. But that in that case also I need 4 and 5 bits. Okay. Clear? Cool. I hope everyone got it. Going for the next one. Next. Try this one. Read that. I'll show you the remaining question. I'll show you the remaining question. Read it carefully here. Oh, sorry. Okay. I think this question, uh, Sajana. Okay. One more person asked me previous one also. I forgot that. That will also I'll do. Sajana, I hope this one you asked. Okay. I hope you got it. Okay. Previous one, boys and girls, just a second. Someone who didn't understand this, I'll repeat this one for them, and then let's go back. I think there may be multiple people also. For boys and girls who asked for a repetition of this bookshelf question, just listen carefully. We have Rajni wants to create a data type for number of books in her bookcase. The shelf can accommodate a maximum of 75 books. So in one shelf, she can maximum accommodate of 75 books. Okay. Now she allocates 7 bit to the data type. Okay. So for storing the 75 books, to represent those books, she created one data type called 7-bit data type. Okay. 7-bit data type she created. Now after that, later another shelf is added to her bookcase. So we got one more shelf. In that one more shelf, using the same data type, how many books we can store more? That's the question, right? The same data type, storing the number of books in our bookcase. What is the maximum possible capacity of our newly added shelf? In this shelf, how many books she can store is the question. So total books we have total number of number which we can represent using 7-bit. 7-bit, what is the maximum number you can store? 127 number you can store. 127 is the number which we can store. Right, the maximum is. Okay. Actually speaking, what will I store here? 0 to, I mean, if I tell book number 0, I'll store till book number 74. Now from 75th book to 127th book, I'll store here. Right, 76th book or 75th book, something like that. Okay. So from 76th book to 127th book, I have to store here. If I consider from 1. If I consider from 0, I have to write 75th book to 127th book. So how many books we can store here is our question. What is that? Simply 127 minus previous book stored. 127 minus 75. That's all right. 75 books were stored. Count of books. I'm not talking last book number of books. 75 books were stored. 127 numbers we can maximum store. 127 minus 75. What is that? 52 books she can store here. 52 more books she can store here. With the 7-bit number. They are not asking generalized capacity of the book. Yes. They're asking with the 7-bit number, how many books she can store in the second shelf. 52 books she can store, which is nothing but 127 minus 75. Understood? Someone who asked me to repeat this. I hope now it's more clear. Hope that person is in the meeting. Okay, cool, super. Okay, just going back to the previous question which you were trying. I think this one you were trying. Everyone done reading this question? Parul takes as input two numbers, 0, A and B. A and B can take integers values between 0 and 255. She stores ABC as 1 byte data type. 1 byte means what? 1 byte means what, boys and girls? How many bits? 8 bits, right? Okay, 8 bits. Okay. Now she writes the following code to process A and B and put the result in C. Okay. Before getting into that, what is the maximum number you can represent using 8 bits? Using 8 bits, what is the maximum number you can represent? 255. Yes. 8 bits. 8 bits is 255. Sanjana, that is 1023 is for 10 bits. For 10 value is 1024. Okay, calculate that carefully. So 8 bits 255. So 255 is the maximum you can store. Now, for surprise, her program gives the right output with some input values A and B. It gives an erroneous answer for others. For which of the following inputs will it give wrong answer? That means what? Which are the numbers giving result more than 255? We have to check. That's all right. Am I right, person else? For what numbers the result is more than 255, we have to check. Can you check that? See the options. For which numbers it will give the result more than 255. Super. I guess everyone got it. Check that once again carefully. For which numbers? Expression was what? Expression was A plus 2B. I hope you remember that expression. A plus 2B is the expression. A plus 2 into B was the expression. What is 10 plus 200 into B? What is the result we get there? It is 410. Am I right? 10 plus 2 into 200, which is nothing but 410. Can you represent 410 in 8 bits? No, it's not. So answer is this. This we cannot represent. Okay, but just cross check the remaining also once. 50 plus 100 into 2, which is nothing but 250. Can we represent 250 in the numbers? In 8 bit? Yes. Like this one, 200 plus 10 into 2, which is 220. Can we represent 220? Obviously, yes. This one, 100 plus 50 into 2, which is 200. So we can represent all of this. Only thing which we cannot represent is 410. I mean, this answer we cannot represent. Got it, everyone? Understood that? I hope it's clear, everyone. Can I go for the next one? Okay, we'll try one question. Let's see this. Please try it, everyone. Easy one. Everyone can do it easily. Just think carefully. You will do it. Got the answer, everyone? Yeah. So Prashant takes two integer numbers A and B, whose values can be between 0 to 127. He stores them as 7-bit numbers. 7-bit numbers means what is the maximum number we can represent? Boys and girls, 7-bit number means what is the maximum number you can represent? 127. Okay. He writes the following code to process these numbers to produce a third number C. How many minimum bits should Prashant store C in? For storing C, how many bits you need? 7 bits, 8 bits, few says 7, few says 8, few says 6. Worst case, think worst case, both possibilities here. See, it can be, it is A minus B. You know what, whether A will be 0 or B will be 0? Not sure, right? It can be 0 minus 127 or 127 minus 0. Both can be possible, right? Both can be possible. That means what? Minus 127 to plus 127 without represent. If you want to represent minus 127, how many bits we need? 7 bits we can represent only 127. Can you represent minus 127? No. For that reason, we need 8 bits. Understood that? Because minus 127. Because of minus 127, I need 8 bits. Both negative and positive results I can get. So I have to consider 8 bits as the answer. Yeah. To represent sign also, if you want to write the number with sign, it should be 8 bits. Because the result is going to be negative result also, right? You are not sure. They didn't mention that. Okay, what they will tell, in some cases they will tell always the result is positive. In that case, what will answer? They mentioned in the question that the result is always positive. In that case, we'll consider 7 bits. But they didn't mention anything like that, right? There can be minus 127 or plus 127. So the answer is 8 bits. If the result is always positive, 7 bits would be the answer. Okay. Understood that? I hope everyone is clear with this. Cool. Okay. So yeah, very similar question. I think this one also you can do. Let's try. Do this. After this, we'll take a break. Okay. Last question. As of now. Do this question, everyone. Question else, please do that. Think both extreme cases. Here also they didn't mention anything like positive or negative number, nothing like that. So we have to store both of them possible. So try to find the extremes of positive extreme, negative extreme, both extremes. 0 to 31 numbers are given. Numbers are 31, but what is the result? Don't think of the numbers, think of the result. What are the results possible? Person else, tell me the results which are possible. 2 into A minus B. What is the positive extreme? 62 is the positive extreme. Negative extreme is minus 62. Am I right? So for storing minus 62, how many bits we need? We have to think. For 62, how many bits we need? Positive 62. For 62 itself, we need 6 bits. If I have to store minus 62, I need 7 bits. Right? So answer is 7 bits. Understood, everyone? Answer for this is 7 bits. Clear? Okay. Yeah. That's all for now. We can take a lunch break. Okay. If people who have any doubts, whichever the question it may be, you can ask. But for people who is very clear with it, you can leave. I'll just repeat the questions which are not clear. But maybe for the people who has doubts, I'll explain them. See here, the result maximum positive number and maximum negative number, what is it? Calculate. So it can be 2 into 0 minus 32, or it can be 2 into 32 minus 0. These are the both extremes possible. Positive extreme possible is 2 into 32 minus 0, which is nothing but 62. 64, sorry. 64, sorry, 31, right? Not 32, 31. 31 means positive extreme possible is 31 into 32, 31 into 2 is 62. Okay. Negative extreme possible is minus 62. For storing 62 itself, for storing minus 62, how many bits we need? Okay. For storing 62, how many bits we need? positive 62 without sign. If I want to store, how many bits I need? I need like 64 is the number, right? 63 is the number. What is the number which we get 63? 6 bits, right? 2 power 6 minus 1, 63. Right? 6 bits I need for only storing the number. If I want to store sign also, what do I need? I need one more bit. So I'll add one more bit called 7. So total answer is 7 bits. This 1 bit is for sign, this negative sign. For storing 62, 6 bits. But if I want to store sign also, I need one more bit. That's why the answer is 7 bits. Clear? Got it, I hope. Okay, if it's clear, thank you. You can leave now and we'll just join it after lunch break at 1 exactly. Okay. Someone asked me about please explain matrix boundaries I and J. Okay. Matrix boundaries is very simple here. Just try to see that numbers, indexes. Look at the screen. These are the indexes, right? I hope the indexes are visible to you. Are the indexes visible to you? In this indexes, I and J, I value is first value, J is the second value. So in this I, J, if you want to print the first line, what are the indexes of I? What is the index of I? Common index 0. So I is 0. That is a common index for line. Last row, what is the common index we can see? 4. Which one? Is 4. So first row, last row. First row, row 1. Row 1, I is 0. Okay. And last row, what is that? I is 4. Like that. Same way we have to consider last column. In the first column. What is the common thing you can see in the first column? J is 0. J is 0. In the last column, J is 4. You observe that? That's what we are writing. So if you want to print these borders, we'll write these conditions only. I is 1, I is 1, I is 0 or I is 4, or J is 0 or J is 4. These are the 4 conditions we write for on the 4 boundaries. Got it? 4 boundaries. Hope you understood that. Someone who asked me. Clear? Okay. Yeah, that's it. Same way you can see diagonals also. Diagonals will be always 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. For this primary diagonal, I and J will be equal. For secondary diagonal, if you add I and J, you will get the same result always. 0 plus 4, 4. 1 plus 3, 4. 2 plus 2, 4. 3 plus 1, 4. 4 plus 0, 4. Like that. If you want to print diagonals, we can print through that. Okay? That's it. Sharing questions, I'm not sure whether I can do it or not here. I'll check because these questions are screenshots. A lot of questions are screenshots, so I'm not sure whether I can share or not. I'll check with the team and I'll let you know that. Okay. Cool. Any other doubts, anyone? If not, you can take a lunch break and come back exactly at 1. We'll start the session exactly at 1. Okay. Thank you. See you at 1, boys and girls. If no doubts, I'll close.